Hello, dear students. Today we will discuss projection of solids. I'm sharing my presentation. I have got it the courtesy of faculty from Don Bosco Institute of Technology, Bangalore. So let us see how to differentiate, how to classify solids, and how we can project solids in principal planes of projections. So firstly, we can classify solids in two categories. Group A, having top and base of same shape. Group B, having base of some shape, it may be circular, it may be polygonal, and at the other end, we have one point as a top, which is called apex. Cylinders, prisms, these are the category A solids. On the basis of polygonal base, solid is named after this. For example, triangular base connected with three rectangular faces is triangular prism. Two square bases connected with four rectangular faces, it is square prism. Two pentagonal bases connected with five rectangular faces, it is called pentagonal prism. Likewise, hexagonal prism is there. And a cube, we know it has six square faces. On the other hand, group B, one circular base and one apex. A triangular pyramid, a square pyramid, a pentagonal pyramid, and a hexagonal pyramid. Tetrahedron is a solid having four equilateral triangular faces. Some parameters which are of concern when we are going to solve the problems. We will take an example of these solids: prism, pyramid, cylinder, and cone. So this is top face, rectangular face. These lines are called longer edges. In case of square prism, it has four longer edges. This is called corner of base or base corner. It will have four base corners. Edge of base, this is base. Likewise, in case of pyramid, this is apex. This is slant edge, base, edge of base, and the corner of base. This is called triangular face. In case of cylinder and cone, we don't have visible edges on the surface because the surface are curved surfaces. So these are the imaginary lines which are called generators. A line which generates the curved surface is called generator. Imaginary line generating curved surface of cylinder or cone is called generator. This is base. This is apex in case of cone. This is base of cone, right? Sometimes we come across truncated solids. So this one is truncated cone. This is truncated cylinder. This is truncated square pyramid. And when this section part is parallel to base, it is called frustum of that solid. For example, this one is frustum of square pyramid. This one is frustum of cone. So keep these points in mind when we are observing front view. XY line represents horizontal plane. So let us take an example of a cone. When we see a front view of cone like this, it means we are looking at the cone which is standing in HP on its base. In this case, axis of the cone is perpendicular to HP and of course parallel to VP. When we see the front view like this, it means the cone is resting in HP on one point of base circle. Still, axis is parallel to VP but inclined to HP. And in this case, a cone is resting in HP on one of its generators. Still, axis is parallel to VP and inclined to HP. Likewise, when we are observing top view, XY line represents vertical plane. So similar is the case. This is a cone standing in VP on its base. And of course, here axis is perpendicular to VP and parallel to HP. Second scenario, resting on VP on one point of base circle. In third case, resting in HP or lying on VP on one of its generators. Axis parallel to HP and inclined to VP. So these points can be kept in mind while solving the problem of projection of solids. So we'll see further in this slide how to solve problem related to the projection of solids. But before that, we have to keep this thing in mind. When we have a solid having axis inclined to both the planes, it is solved in three steps. So these are steps. Step number one, in first step, we have to assume the solid standing on the plane with which it is making an inclination. For example, if it is inclined to HP, we have to assume it standing on HP. And if it is inclined to VP, we have to assume it standing on VP. When we are drawing it standing on HP, we will see true shape of base in top view. When it is standing in VP, front view will be the true shape of base. Likewise, step number two, in second step, in first step, we will draw true shape of base and then we will proceed to draw the front view or the top view as the case may be, having true length of the axis. Then comes the step number two, considering solid's inclination, means position of axis with the other plane, we have to draw the second step. And then in third step, the second condition means inclination to the second principal plane is to be considered in the third step. So we will see these three steps in the next solve problem. Let us see the case of square pyramid. A square pyramid is having 40 mm base height and axis inclined, axis length is 60 mm. It is resting in HP or ground on its triangular face when the vertical plane containing the axis is making an angle of 45 degrees VP. So we have to draw its projection. Now we see the axis, the solid is resting in HP on triangular face. It means its axis is given inclined to HP. So in first case, we have to assume this square pyramid standing in HP on its base. When it is standing in HP, it means we will see true shape of base in top view. So we will start from base true shape. This is XY line. We have true shape of base of square pyramid in HP. We name it as A, B, C, D, and O. We will project its front view. We are having B dash, A dash, C dash, D dash, and O dash. Now, in second step, we have to consider the first condition given in the question. It is resting in HP on its triangular face. So we are having triangular faces in front of us, A, B, O, O, C, D, which are in the form of a edge in an edge view. So we will redraw this solid, keeping one of the edges on XY line. Let us see. So the solid has been redrawn, keeping OCD on XY line. It means now the pyramid is resting in HP on its triangular face. Then project it to the top view. Take projector from previous view. Locate the points. Now, in this case, we will be having some edges which are hidden, some edges which are visible. So to identify, we have to draw proper outline. Means all the points lying on the outline are to be joined with the dark lines. Here in this case, this is A, B, C, D, and O1. You can note down these points, draw proper outline, dark, then decide direction of observer. Please keep these points in mind. Then select nearest point to the observer and draw all the lines emerging from that nearest point as dark, and select farthest point and draw all the lines remaining emerging from that farthest point as dotted lines. So let us see these points here: A, O, B, C, and D. They are lying on boundary. So we have joined with a dark line. Then we decided direction of observer. While observing top view, we will see from this direction. And in this case, A and B are the nearest point. So all the lines emerging means A1 with B1, it will be a dark line. We come across CD, D is the farthest point. So lines emerging from CD, which are DO and CO, these will be the dotted lines. Now, taking the third condition, angle with VP as 45 degree. So we have to redraw this view, keeping the condition satisfied. Means axis, plane containing the axis inclined to VP at 45 degree. Take projectors, locate the points, join the points lying on the boundary with the dark line. Then direction of observer, this one, farthest point O, nearest point C. So only one line was remaining, that is dotted. Right? If the case is like take apex away from VP or toward the observer, then it would have been drawn like this, and accordingly, the front view will be something different. Let us see another example. A cone having 40 mm diameter and 50 mm axis is resting on its generator on HP while making 30-degree angle with VP. So let us take XY line, standing on HP on its base. Then we draw the front view after naming this. We can divide this top view in 8 or 12 parts, right? Here it has been divided into 8 parts. We can divide it into 12 parts, then project it to the front view. Now these are OA, OB, OC, OD, OF, and so on. They are all generators. We have to make it rest on HP on one of its generators. So we'll consider the generator present in true length and at present OA and OE, O dash A dash or O dash E dash are in true length. So any one of these can be made to lie on XY line. So we have redrawn this, keeping O dash E dash on XY. Then take projectors to the top view, take projector from previous view, locate points and complete the view. Now, considering the inclination with VP, we have to redraw this view, then project it to the front view, locate points and complete the view. So this is just overview of projection of solids. If you have any doubts, we can see it again. That's all for now. Thank you.